Welcome back. This is an Aleks homework video on identifying strong or weak acids and bases from a sketch. So if you're going to do a sketch, you basically have to do the little red balls for oxygen, the little white balls for hydrogen, and then something else for a conjugate of an acid or a base. So let's just look at what they use, and then whatever you're seeing has to be from what you know about acids, and that's what they're testing you on. So let's look first. What I wrote down here was pictures from an acid. So when it says HA, hydrogen is donated by an acid. So the A here just means anything that's left over once that hydrogen's gone. So this is the conjugate base, and that's why on the right side it's A negative, because the base is going to be negative. The hydrogen is going to take the positive charge and become a proton and then leave a negative anion behind. So anything that is HA here is going to be a blue dot with a white dot. Okay, the white is representing the hydrogen. Now in the case of an acid, it is going to join, that hydrogen that's donated is going to join to a water molecule and become hydronium. So the water molecule looks like Mickey Mouse, and the hydronium is three white hydrogens on that oxygen. So think of the acid as a 2-part, the water as a 3-part, the hydronium is a 4-part, and then the blue ball by itself is whatever's left over. That's the conjugate base. If you have, now that would work the same for acids and bases, or I'm sorry, acids and strong acids. Just remember that if you have a strong acid, it's completely going to go away, and there is not going to be any HA in the mixture. If there's HA at the end, then you know it's going to be a weak acid, because strong acids by definition completely dissociate. There will be no HA left. All right, so in the case of a weak acid, at the end, you're going to have a mixture of these 4 pictures. If it's a strong acid, you'll have water, hydronium, and then the blue dot, the base. And so that's how you can tell acids. Bases are going to be basically the same. All the strong bases are the first and second group hydroxides. And so the bottom picture here is the strong base. The strong base will completely dissociate into the B+, which is the conjugate acid of that, whatever B is, that blue dot, and then a hydroxide. So a strong base will have nothing left over. There will be probably, I should have put water there, there would probably be some water in it, and the blue dot for the conjugate acid, and the red dot with a hydrogen, the oxygen hydrogen, that's hydroxide. So if you have a strong base, you're not going to have any BOH mixture. You'll have water, you'll have the blue sphere, and then the hydroxide. For a weak base, the one in the middle there, weak bases are going to essentially steal a hydrogen from water. So you're still going to have hydroxides. It's a base. You're going to end up with hydroxide, but you're going to end up with a HB+. That's the conjugate acid of that weak base. So in the case of a weak base, you're going to have a mixture of all 4 of these. In the case of the strong base, you're going to have a mixture of the 3, the water and the B+ and the OH-. In the case of a strong acid, you're going to have the 3. You'll have the water, hydronium, and the conjugate base. In the case of a weak acid, you're going to have all 4. So this was the example that I was given. So a strong acid here, I needed to have just the conjugate base, that's the blue sphere, water, that's Mickey Mouse, and then the hydroniums. That's all. You're not going to have any of the HAs at all because it's strong. It completely dissociates. Strong bases likewise, I'm not going to have any of the BOH. I'm going to have water there. I'm going to have the blue dot, which is the conjugate acid, and then I'm going to have the OH. So here was a strong acid, strong base. I hope that helps.